Ciao friends, and welcome to a new Unplugged video. Today we introduce a new feature in the upcoming new release of DAX Studio. The new feature is the Server Formula Engine Benchmark. The idea is to provide an index that measures the speed of the formula engine on a particular server. The goal is to be able to predict the expected difference in performance once you deploy your model to a server. Usually you test your model on your local desktop, your local notebook, and the performance of your desktop or notebook could be very different from the server. Of course, there could be a difference in the volume of data, of the number of cores. But when it comes to the calculation in the formula engine that is single-threaded, just the difference in the clock speed and the type of the CPU is more important. But how to analyze that? We run a small benchmark, we get a number, and we can have an idea about what to expect. So let's start with a demo. I prepared two instances of DAX Studio, one connected to a Power BI desktop model that I have locally, and one connected to the very same model published on Power BI service. My goal is to show you a new feature that we have in DAX Studio, which is this advanced Server Formula Engine Benchmark. But before showing the feature, I want to show you what happens when I execute a query. So this is a DAX Studio connected to my local Power BI desktop, and I created a query that is intentionally slow. So if I run this query with the server timings active, I can see the execution time. Of course, you can do this work of preparing the measure, optimizing the measure with DAX Studio, usually working locally with your local analysis services or Power BI desktop. For example, now I see that I have this execution time. Let me copy this into the clipboard. So this is the timing for my code, and I copy this in the clipboard so I can restore this at any moment. And I see that this query has been executed in almost 5 seconds and almost 2 seconds of the formula engine and so on. So far, so good. So just to highlight that the numbers I'm mentioning are these numbers. So the total time and the formula engine time. Of course, we also have the storage engine and the storage engine CPU. Now, what to expect? The idea is that when I deploy my model to Power BI service or to analysis services on a server, also on premises, I may expect a different performance, slower or faster, it depends. So, do I have a good machine or not? And here is what we can do. So instead of doing a trial and instead of trying the same query several times in different situations, we can just run this benchmark, server FE benchmark, server formula engine benchmark, that run, let's click run, that run a number of times the same query to the formula engine, which is a query that doesn't require any calculation in the storage engine. This query is basically measuring the speed of the CPU, because the only thing that matters is how fast is the CPU. We are not using RAM, you are not using other services, we are not doing I/O, and the result we obtain is also detailed here. We see the duration of all the queries that have been sent, to the engine. But the more important number is this one, the benchmark, 352. So we know that this is 352. Now, is this good or bad? Oh, I can tell you, this machine is relatively fast. So this is a good machine, fast, very modern CPU. I expect other machines to be usually slower, at least in 2023. But let's try to see what happens if I run the same benchmark on the Power BI service where I can deploy my model. So I open the other DAX Studio, and I run just the benchmark. You see that I prepared the query. That is a query that has more activities. I just want to run the benchmark now. So I want to measure what is the index, because I want to predict what could be the execution time of my original query in Power BI Desktop once I publish this query to the service. Usually the service actually has slower CPUs, but they usually have many more cores. So the outcome could be different, because especially the storage engine could use the parallelism of the many cores available compared to usually what you have locally. And so there could be a different result in the storage engine. But when I have a slow query for the formula engine, that is more predictable. So let's take a look. The number we have is 111. So I write the number here. So the index is 111.88. What does it mean? If I compare the number we have in the cloud, 111, with the number I have in my local machine, 352, it's easy to predict my machine is at least 3 times faster than the server, at least for the formula engine. Which means that if I look at the server timings of the previous query that I saved before, because in the meantime the benchmark changed everything. If you remember, this was the result. Let's close this way. This was the result I obtained with the execution, with the local execution of my previous query. A total time of 5 seconds, a total formula engine time of 2 seconds, 40% of my query. So let's run now the same query in the cloud, in the same database that I published to the cloud. So I can maximize this. I can go back to home, server timing is active, clear on run. So I go to this visualization, and now we have to wait a few seconds that the query is executed. Sometimes, of course, we might have also problems of noisy neighborhoods, so we could have other queries running from other users in the same workspace or in the same tenant. So actually, it is not so predictable what we can get as a result. But the idea, I would be surprised to have a query that is much faster than what I measure, because I know in advance that my local model is 3 times faster than, no, my local desktop is 3 times faster than the CPU running in Power BI service. So let's take a look, maybe that we had an error. Yes, it is. So let's try again to run this query. Now query started, so probably I made the selection of something that was not expected. So I run this query again, and finally we will see the execution time. As you see, we have something that is not 3 times slower. This is important. So we see that actually the formula engine benchmark is a measure that can provide you a hint, but you don't have to take for granted that that is the difference that we have. You see that we have sorry, I have to go back to this snipping tool. This was the execution time I had last time. We had, let's focus first on the formula engine. We have almost 2 seconds. Now we have a 3 seconds and a half. So actually, it seems that the behavior of the formula engine benchmark is not the same that we have for a more complex query. So this is already a difference. We see that it is lower, to be honest. So it is almost twice lower, but it is not 3 times slower. So you have to take this index with a grain of salt. So it's not something that you can apply in a blind way. But I have found that this can be useful in general to see the behavior of the query. For example, something that is not different is the ratio between the total storage engine CPU that we have in one case and in the other case. Of course, the parallelism is better on the service, but the total amount of time is actually almost 3 times, maybe more, than the storage engine CPU we had when we executed the query locally. So locally we had this, and on the service we had this other number, which is more than 3 times. So once again, this is not something you have to use to assume that that is exactly the ratio that you have to expect. But it's good to know that, for example, if you have a local server that is twice slower than your local desktop, or the opposite, you can have an idea about when you reach a certain goal for the optimization of a measure, you have an idea about what you could expect once you publish the model in terms of will it be slower or faster. Don't assume that the ratio is exactly what you get. That is just a generic index that cannot be applied to any measure, but is a quick way to have a prediction of what to expect, faster or slower queries. We have seen that the new feature, the server formula engine benchmark, gives us an index that can help us understanding what to expect when we deploy a model to a server. Of course, this way we can actually get a single number to get a baseline for the performance of a server without having to spend too much time evaluating the clock speed, the RAM, the CPU model. Of course, more cores with a large database is important for the storage engine, but the formula engine is not affected by the fact that you have more cores. The only important thing is how fast is the single core of your machine, and now you have an index to measure that. As usual, enjoy DAX!